Today, we're diving deep into something that's really immediate, quite personal actually. How these dramatic shifts on our planet are already affecting us directly, right now.
Yeah, it's not a future thing anymore.
Exactly. We've pulled together a really fascinating collection of sources, articles, YouTube transcripts that lay bare the human impacts. We're going to focus quite a bit on heat waves, that growing threat.
Which seems to be everywhere in the news lately.
They really do. So our mission today is to sort of uncover what these sources reveal about these intense day-to-day changes, stuff touching everything from your health to your home, and also examine the ways humans are adapting or, well, maybe struggling to adapt.
And what's truly striking when you start looking through this material is just how pervasive it all is already. It's not some abstract environmental issue, is it? It's deeply personal.
Right.
Touching health, food, livelihoods, even where we can realistically live.
So let's start with that big picture then. Because the sources, well, they immediately show how widespread climate change is shaping our daily lives.
Yeah.
Take health. The headline seems clear.
Well,
Frequent, more intense heat waves, leading to serious problems like heat stroke and tragically even deaths. But that's just the start, right?
Oh, absolutely. Beyond the direct heat stress, you've got warmer climates creating, well, perfect conditions for mosquitoes. So diseases like malaria, dengue, they're spreading, moving into regions that never really saw them before.
Wow.
And then there's the air you breathe. It's actually deteriorating. More ground-level ozone, smoke particles from forest fires, and this stuff travels thousands of kilometers.
So it's not just a local issue if a fire is far away.
Not at all. And it directly causes more breathing problems, aggravates allergies for, well, loads of people.
It feels quite insidious. I mean, the sources even mention our sleep suffering.
Definitely. Hotter nights aren't just uncomfortable. They genuinely mess with your sleep cycle. That leads to fatigue, mood swings. It just makes you less equipped to handle everything else the next day.
And speaking of stress, the picture for food and water seems pretty stark too. Unpredictable rain, long droughts, higher temperatures, makes growing crops harder.
Much harder, leading to less food potentially, and almost certainly higher prices for staples. You know, wheat, rice, coffee, cocoa are mentioned specifically.
And it's not just how much food is it. There was something about the quality.
You're right. It's not just quantity. Heat can actually reduce the nutrient content in some key crops. So the food we do get might be less nourishing.
Okay, wow.
And for water, it's sort of a double hit. Glaciers, vital freshwater sources, they're melting fast. Plus, rainfall patterns are changing, affecting rivers. And at the same time, our oceans are getting more acidic.
From absorbing CO2.
Exactly. Which disrupts the whole marine food chain, especially fish populations that millions rely on.
And we're seeing the results on the ground already in cities.
Yeah. Water shortages are becoming common. Reservoirs running low, water rationing. Sources mention places like Pakistan, India, parts of Africa facing these risks daily. It's a present danger.
And the economic impacts must be huge, rippling through communities.
For sure. Direct hits on jobs, farming, fishing, tourism sectors that depend on nature being somewhat predictable.
Which it increasingly isn't.
Right. And that unpredictability comes with a massive price tag. Beyond just food prices rising. Think about repairing basic infrastructure. Roads literally melting, railways buckling, power lines failing under extreme weather.
So more power outages for us, maybe higher electricity bills from everyone cranking the AC.
That's the likely outcome, yeah. The demand just skyrockets during these events.
And there's the really fundamental impact, I suppose. The threat to our homes. Rising sea levels mean beaches eroding, losing vital habitats like mangroves, coral reefs.
And those habitats aren't just pretty. They're crucial protection against storm surges. Losing them makes coasts more vulnerable.
Which must lead to people having to move. Forced migration.
Absolutely. We're seeing coastal areas going underwater, entire islands threatened, or land just becoming too dry, droughts, expanding deserts. And it's not always slow, creeping change. Sometimes it's sudden.
Like violent storms.
Exactly. Hurricanes, massive floods, uprooting whole communities instantly. This leads to a rise in, well, what people are calling climate refugees, putting huge pressure on cities, straining resources, and people are forced to find new ways to make a living, often far from home.
And all of this takes a toll on mental health, doesn't it?
A significant toll. The sources really highlight this emergence of climate anxiety. It's not just a vague worry. It's manifesting as real depression, stress, PTSD even.
Stemming from that uncertainty or
Right.
direct experience.
Both. The constant bad news, the uncertainty about the future, or the direct trauma of losing your home or livelihood, it really raises an important point, doesn't it? We often talk about climate change like it's purely environmental or something for the future, but these sources just hammer home that it's here now, it's personal, it's affecting our health, our peace of mind.
The scale is just immense already.
It really is.
Okay, so let's zoom in then on one of the most immediate threats, heat waves. What exactly are they? Why are they getting so much worse, sometimes in places you wouldn't expect?
Well, the basic definition is pretty straightforward. A heat wave is just an extended period of abnormally high temperatures day and night for a specific area.
And abnormal depends where you are, right?
Yeah.
But 30 degrees in Switzerland is major, but maybe less so elsewhere.
Exactly. The threshold varies. 30 degrees C might be the trigger in Switzerland, but it'd be much higher in, say, Greece or India, where people are more used to heat.
Is there any upside? Can we see them coming?
Actually, yes. That's one difference from things like flash floods or tornadoes. Heat waves can often be predicted pretty accurately, sometimes up to 7 days in advance.
How do they form? What triggers them?
It's specific weather patterns. Usually a big high-pressure system settles in. It pulls in warm air, pushes it down towards the ground, which compresses and heats it even more. Plus, it stops clouds forming and rain falling. A very clear setup.
But when that setup hits a big city, they become heat traps.
Perfect heat traps. Concrete, asphalt, lack of green space. They absorb and retain heat incredibly well. The sources raise serious questions about future heat waves hitting maybe 50 degrees C in some cities.
50 degrees Celsius, that's hard to even imagine. And Paris was flagged as particularly high risk.
It was, in 2023, identified as the large European city with the greatest risk of dying in a heat wave. And we don't have to look far back to see why. The 2003 heat wave there was catastrophic.
I remember reading about that. It was awful.
Clearly, their normal death rate was around, 38 a day? It suddenly jumped to 650 deaths over just 3 days.
It's like 3 plane crashes.
Exactly. In a city just not equipped for that kind of prolonged, intense heat, most deaths were in those small top-floor flats, often with zinc roofs. They basically became ovens.
God, especially for the elderly or people living alone.
Precisely. And the authorities face huge challenges. Preserving bodies. Many relatives were away on holiday. They ended up using enormous refrigerated trucks. One source described it as like scenes from a war.
Just grim. And the thought of 50 degrees there.
It feels unbearable. The source mentioning it implied, no one left here who could actually escape that kind of heat.
And this isn't just a Paris problem, is it? Europe generally seems to be warming fast.
Faster than any other continent, actually. Average temperatures there are already about 2.2 degrees C above pre-industrial levels.
So heat waves are becoming more intense, partly because the baseline temperature is just higher to start with?
That's a huge part of it. The starting point is hotter than ever, but there's another factor. Scientists are looking at something called double jet states.
Double jet states. What are those?
Think of the jet stream, those fast-flowing air currents high up. They usually bring cooler, wetter weather. But sometimes these streams can split into 2 branches over Europe. This split redirects weather systems, often leading to these really persistent high-pressure zones, more intense, longer heat waves.
This is happening more often.
Apparently, yes. These double jet states seem to account for almost all the upward trend in heat waves over Western Europe and about 30% across the wider continent. It's this combination, the higher baseline, plus these atmospheric changes driving these record-breaking temperatures.
And it's not just the physical environment. Heat messes with us mentally, too.
It really does. Experiments show some interesting cognitive effects. Our perception of time can change. Time seems to pass faster. We might make decisions quicker.
But maybe not better decisions.
Exactly. We tend to make more mistakes under heat stress.
And how about how we interact with each other?
That can change too. People can become less patient, maybe more aggressive in group settings. There's a physiological link. The body releases survival hormones, partly to manage water loss. But a side effect is it makes us focus more on our own needs, less on others. We literally become less inclined to help someone else out.
Wow. That's quite a profound impact.
It is, and connecting it back, that Paris example really underscores the immediate tragic human cost. And the science of why it's happening, especially in Europe, is quite eye-opening. It's not just discomfort. It's a fundamental shift, potentially altering how we function, how we interact, pushing us way outside our normal zones.
So what does this all mean for us, then? Can we actually adapt to this level of heat? Our sources look at this from 2 angles. Our own bodies, and how our cities are changing. Let's start with biology.
Okay, so fundamentally, our bodies are always generating heat just by burning calories, living, and we have to get rid of that heat to keep our core temperature stable, around 37 degrees C. Our bodies just don't tolerate much fluctuation there.
How do we do that? How do we cool down?
We have specialized heat sensors, nerve cells in our skin, organs, even the brain. They detect rising temperatures and signal the hypothalamus, the brain's sort of thermostat. The first response is usually to increase blood flow to the skin, trying to radiate heat away.
And if that's not enough,
Then we sweat. That's the big one. It's a key evolutionary adaptation. It's what allowed our ancestors to, literally run prey to exhaustion in hot climates. Sweating kept them cool enough to keep going.
and can we get better at handling heat over time? Acclimatize.
Yes, definitely. If you're exposed to heat for several days, your body starts making adjustments. Your core temperature might run slightly lower, your heart rate response improves, and crucially, you start sweating sooner and more efficiently. Better evaporative cooling.
How long does that take?
The sources suggest the full process takes about 2 weeks, around 14 days.
But there are limits, right? Does acclimatization always work?
No. And this is critical. It works well in dry heat, but in high humidity, your sweat can't evaporate properly off your skin.
So the cooling mechanism fails.
Exactly. And that leads to dangerous internal overheating, even if the air temperature itself isn't record-breaking. This is where wet bulb temperature becomes so important.
Right, I've heard of that. It combines temperature and humidity.
Precisely. It's a much better measure of actual heat stress on the body than just dry temperature alone. For example, a 26 degrees C day might feel fine if it's dry, maybe a 19 degrees C wet bulb temp. But once that wet bulb reading gets over 20 degrees C, it starts feeling unpleasant. Over 30 degrees C, it's dangerous.
And there's a lethal limit.
There is. It was thought to be around 35 degrees C wet bulb, assuming you're, naked and doing nothing. But recent experiments suggest that limit drops quickly with even minimal activity, maybe down to about 31 degrees C wet bulb.
And even lower for vulnerable people.
Yes, older people, those whose bodies can't sweat as effectively. Their critical threshold is lower still.
That sounds very concerning, especially for human parts of the world.
Extremely. The predictions are sobering. One estimate suggests maybe 1.5 billion people in South Asia could face these dangerous conditions by the end of the century. It could be a major driver of climate migration, pushing people towards cooler, less humid areas, especially if they lack access to cooling or protection.
So our biology has limits. What about adapting our cities, our built environment?
Yeah, because most cities were built assuming relatively stable temperatures. Now they need major changes.
What kind of changes? I saw mention of just painting things white.
That's a simple one, surprisingly effective. White surfaces reflect sunlight, stop roads and buildings absorbing so much heat. But it goes much deeper into urban physics, how cities are actually laid out.
Urban physics, how does that work?
Research from MIT by Volpon shows the arrangement of buildings is key. Think about those neat, grid-like layouts common in the U.S. They can actually amplify heat by maximizing something called thermal coupling. Basically, heat reflecting back and forth between building surfaces, trapping it.
Oh, okay.
Contrast that with older, maybe more disorganized European city layouts. They often have less thermal coupling, fewer intense heat islands.
So messy is better for heat.
Sort of. The optimal design seems to involve varied building heights and arrangements that minimize that heat bouncing around. It actually resembles many older, mixed-use neighborhoods.
That's fascinating. Is there an example?
Lyon, in France. Their modern P district is apparently 4 degrees C warmer than the old medieval quarter. Even more at night.
And Paris, you mentioned earlier.
Paris is identified as one giant heat island, partly because of its uniform building heights and street widths. That layout intensifies the thermal coupling. The temperature difference between the city center and the outskirts can be up to 10 degrees C.
So what's Paris doing about it? Any big solutions?
Some really ambitious ones, actually. They've built this huge cooling plant deep underground, about 30 meters down. It uses water from the River Seine, cools it to about 24 degrees C using renewable energy.
Ice cold.
Pretty much. And then pumps it through this growing network of pipes across the city. Nearly 90 kilometers now, plan to expand massively, especially to hospitals and critical places.
Is that better than just loads of air conditioners?
Much better environmentally. Standard AC units pump heat out into the street, making the urban heat island worse. This system avoids that.
Clever. What else? Rooftop gardens.
Yep, transforming rooftops into green spaces. They absorb rainwater, which then evaporates and cools the air naturally. Plus, Paris has a proper heat plan now. Authorities check on vulnerable people. There's an app showing cool islands parks, water features where people can get relief.
They're even running simulation exercises, testing their response.
They did one in October 2023, yeah?
Testing resilience. They're taking it seriously.
But even with all this adaptation, the economic cost is still huge.
Undeniable. Heat waves cost the EU something like 130 billion euros between 1980 and 2022. Spain was hit hardest. Their farming sector took massive losses just last summer from heat and drought.
And there's a vicious cycle, right? Dry soil makes heat waves worse.
Exactly. Parched soil at the start of a heat wave just reinforces it, absorbs more heat, can't cool through evaporation. It accelerates desertification like we're seeing in Andalusia.
Which brings us to those olive farmers in Jaén, Spain, world's biggest olive growing region. That's the one. 66 million trees. Normally, olives are well suited to dry climates, but these extreme heat waves are hitting right when the trees are flowering,
Burning the flowers.
literally scorching them, destroying the harvest potential. It's threatening livelihoods directly. One farmer, Agustin Bautista, said it just takes a couple of days of extreme heat during that critical flowering window to wipe out the whole year's crop.
Wow. It really highlights that interplay, doesn't it, between our biology, our limits, and how we build our world.
It really does. The scale of adaptation needed, from our own bodies to redesigning cities, it shows the challenge but also the ingenuity. But those economic costs, like for Spain's olive farmers, they show the stark reality when we hit those limits. The cost is immense.
We focus so much on heat waves on land, but the sources point to something equally critical happening in the oceans. Marine heat waves. What are they? And what's causing them?
Essentially the same idea, but in the sea. Ocean temperatures in a specific area get significantly higher than the historical average and stay that way for at least 5 days, often much longer.
How much higher?
Anomalies can be 1 degree C, which doesn't sound like much, but in ocean terms it's significant. But increases of 4 or 5 degrees C have been recorded too.
Does it affect the whole ocean depth?
Mostly, the top layer one source used the analogy of the top of a creme brulee, but they can go deeper, 40, 50 meters, sometimes even 200 meters, and the deeper ones can be more intense and last longer.
What causes them?
So
Similar to land heat waves.
Some similar factors. Changing ocean currents can pool warm water together. Persistent high-pressure systems overhead mean less cloud cover, more direct sunlight hitting the water.
Okay.
And weaker winds are a big factor, too. Wind normally helps cool the surface through evaporation and mixes warmer surface water with cooler water below. Less wind means less cooling.
And less Saharan dust. How does that fit in?
Right. Weaker trade winds mean less dust blown from the Sahara over the Atlantic. That dust normally reflects some sunlight back into space. Less dust means more solar radiation gets absorbed by the ocean. It's another feedback loop.
Can we see the impacts?
Yeah.
Specific examples?
Definitely. The Mediterranean is a hotspot, unfortunately. It's warming 20% faster than the global ocean average.
20% faster.
Yeah, about 0.4 degrees C increase per decade since the 80s. This is allowing invasive species to move in. Barracudas, for example, normally from the Red Sea, are now common around Marseille. They're described as voracious carnivores, upsetting the local ecosystem.
And what about corals? You mentioned Marseille earlier.
It's devastating for them. Water temps off Marseille hit 27 degrees C at 20 meters depth, should be around 23 degrees C. Surface temps hit record highs, the result. Up to 80% of shallow coral colonies died in that 2023 event, double the previous record loss.
And corals are like the forests to the sea, right? Providing habitat.
Exactly. Crucial ecosystems. There's urgent research into whether corals can adapt genetically, but it's a serious race against time.
Are there other major examples? Bigger scale?
Remember the blob, that massive marine heat wave in the North Pacific back in 2013?
Vaguely, yeah. It was huge, wasn't it?
Enormous. Lasted 2 years, covered over 4 million square kilometers. It essentially put a lid on the ocean, stopping nutrient-rich cold water from welling up. Phytoplankton disappeared, crustaceans. The base of the food web collapsed.
With knock-on effects.
Massive ones. Over 100 million Pacific cod died. Tens of thousands of seabirds starved. And a huge bloom of toxic algae shut down the fishing industry.
Just staggering. And the oceans are absorbing most of the excess heat overall.
An incredible amount. The sources say 93% of the extra heat energy from greenhouse gases over the last 25 years has gone into the oceans.
93%.
It's equivalent to the energy of something like 3.6 billion atomic bombs.
That's almost impossible to comprehend.
And that warming is considered essentially irreversible for thousands of years. Driving sea level rise, melting ice, it's a long-term commitment we've made.
And does what happens in the ocean affect heat waves on land? Is there a connection?
There absolutely is. Marine heat waves can stop coastal areas cooling down at night. They can also create turbulence in the atmosphere above them, which can break up low clouds over the coast.
Letting more sun hit the land.
Precisely, making land heat waves potentially worse near affected seas.
And then the aftermath. Heat waves often end with storms.
Colossal thunderstorms, frequently. And when that torrential rain hits baked, cracked ground.
Just runs off, flash floods.
Exactly. The soil can't absorb it. We've seen that pattern time and time again.
And wildfire.
Dry vegetation plus heat, earlier, longer wildfire seasons. And these aren't just normal fires anymore. We're seeing sixth-generation fires so intense, with high winds, loads of fuel, they create their own weather systems. They're basically unextinguishable by conventional means. Catastrophic.
It's such a complex web of interconnected impacts.
It really is. What happens in the ocean definitely doesn't stay in the ocean. That heat absorption is staggering, and the consequences ripple outwards. Land heat waves, storms, fires, it's all linked. Research into predicting these complex chains is so vital now.
So wrapping this up, what does this all mean for you listening? This deep dive, I think, really shows how immediate and personal climate change impacts are now. It's in the air we breathe, the food we eat, our mental health, the places we call home.
Yeah, it's not abstract anymore.
We've seen how our bodies try to adapt, how cities are trying innovative and sometimes old ways to cool down, and how our oceans are struggling with changes that, well, might be locked in for millennia.
The complexity is huge. The interconnectedness, understanding it feels like the first step.
Definitely. It's not just academic knowledge. It feels crucial for navigating what's happening and thinking about adaptation. The sources show incredible human resilience, don't they? Biological responses, architectural fixes, cultural things like the siesta.
True. Humans are adaptable.
Yeah.
But there's a but, isn't there? Given the sheer speed and intensity of these new record heat events, these massive marine heat waves, what is the ultimate limit of our adaptation, both individually and as societies, before we're forced into really profound shifts, entirely new ways of living that maybe we can barely even imagine right now?
That's a really big provocative question to end on. Where are those limits? The challenge feels immense, no doubt. But hopefully, understanding these impacts the science, the human stories, gives us the knowledge, maybe the motivation to act. Every effort does count. Working together, making informed choices, hopefully paving the way for a more sustainable, maybe more hopeful future.